Okay, good morning, good afternoon, good evening. Please pay attention to this. First exercise is calculate the needed heat. You have the formula to calculate the heat. You have a table to write the data on, so you have the mass, 800 grains, the specific heat. Sorry, because I use a dot here to mark the 1,000, you use a comma, so this should be a comma. It's 2,513, okay? Initial temperature 10, 50. The only thing you gotta do is to put it. No? Because you read the formula. Yeah. Multiply and here. That's what I'm doing. You take your phone for something useful, for a change. $800 times 2,513 times 40. 80 millions. The unit for energy is joules, okay? Can I go on? Do I stop? I didn't go to class today. They teach how to write the 8. Can I go on? Come on. It's gonna be long if you're not fast. Can I go on? I go on. Okay, the formula for potential energy is M, the mass, times G times H, the 8. So here we have 20 kilograms for the mass, and the height is 30 meters. So this would be mass times G, that is 9.8, times H. Mm-hmm. 5,880 joules. Can I go on? I go on, okay? Okay, the formula for kinetic energy is half the mass times velocity squared. Okay, so data here is mass, 50 kilograms, and speed, 40 meters per second. You only have to put it in the formula, 50 and 40 squared. Okay? Would be what? 40 square. What? Yeah. The speed is 40 meters per second. Speed is measured in meters per second. This would be 25 times 40,000 joules. Come on. What? No. 90 where? No. 40? 40, 40. Here? Where?
It's 8 because they added 1 plus 3 equals 8. That's the velocity.
That's an error. Should be a 3.
Have to check it. Can I go on? Yeah? This is longest, the longer. This is longer. I'm going to do it step by step. Low. So when something is falling, you have to calculate first the potential energy, okay? That is the mass. Mass is 3 G, 9.8, and 100 meters, okay? Okay, that's the initial energy. The thing you gotta do here is, with that initial energy, that is 2000, which is wrong. Like the initial kinetic energy is 0, and the total energy, you add them, you have this, okay? The total energy is always the same, okay? I'm going to do everything in this first table, okay? To calculate the potential energy, the only thing you got to do is use the same formula, but change the 8, okay? So this would be, the mass was 3 times 9.8, 975. Then with 50, mass 3 times 9.8 times 50. Three times 9.8 times 25. And here's 0. To get the kinetic energy, the only thing you have to do is to subtract this number from this number. Okay? It would be 2,940 minus 2,025. This would be 1,470. This would be 2,000, and this would be. Okay? And that's all you got to do with the table. You get it with the formula m times g times h, and then you subtract this number from this number, and you get the kinetic energy. Okay? I have done all the steps in that table. Okay? You can do the same. Can I go on? You don't have to do this if you don't want, okay? Let's not calculate the speed. I will take it out from the test, okay? Okay, this is the bond energy. To do this, you have the table, and the only thing you gotta do, I'm gonna write here the energy bonds, okay? Please look here, there's an error here, because here I have two water molecules. Each water molecule has two HO bonds, so this should be a 4, okay? And then the only thing I've got to do here would be HH. This would be OO. Then I write here the energies. HO is 467. Here HH is 432. And here 146. Okay? Then I do the calculations. And I get. Here I add. And then I subtract that number from this number, and I get minus 858. Okay? We're almost done. Can I go on? Out. Get out. Yeah. Go on. It's done. Oh, it's done.